With that, I would like to introduce, firstly, Keno Fischer and Lilith Hafner, who will be the first presenters of the State of Julia 2025.
Thank you.
This is what's been happening and what's maybe going to happen. So in this talk, we're going to talk about recent technical developments that have happened in the last year, largely 1.12, so that's things that will come out with the next stable release. We're going to talk about the impact of AI on Julia, use of Julia, and on how Julia interacts with open source. And we're going to talk about, just real briefly, about how Julia language development works, like what caused us to do these things, what goes into what we'll do next year. We'll see. And we'll speculate a little bit about the future of Julia language development. So jumping right into the past, things that we've seen a lot of progress on last year are Julia C, which turns a Julia script into an executable, which is pretty cool, but isn't actually what you're looking for unless you also have the trim option, which is another thing folks have been working on that makes those executables smaller. Going with that, we've got main entry points, and the julia.m flag will launch Julia and automatically run those main entry points, and that helps standardize for various ecosystem tools that want executables and entry points. There's a talk that already happened, State of Trim, that you can watch the recording of, that'll say a lot more on this. And one of the tools that uses that main entry point is PKG, which is a tool many of you may be familiar with. And it now has an apps feature. And that allows you to install a Julia package app, and that is just makes it a little bit friendlier to deploy a Julia package as a user-facing command line application. And there's also a sources section, which lets you specify dependencies that are not in a registry, or not in a registry your users will have. Also there's a workspaces feature, which lets you specify workspaces for your package. Yeah.
All right. I'm not that tall. All right. Good morning, everyone, first of all. So I'm sure most of you have seen one of my talks at JuliaCon before, but for those of you who don't know me, my name is Keno Fischer. I've been working on Julia for more than a decade at this point. Been at every JuliaCon, and this one is no exception. I'm very happy to give the State of JuliaCon talk with Lilith this morning, or as I like to call it, Julia core developers do slide karaoke. We'll talk about it a little bit, but these slides are the product of many, many people putting in some late hours last night to put together some highlights. So, you know, we hope that you get an idea of what it is that people are working on, but certainly it is not everything that people are working on. And I also want to make sure that I express that this is the work of many, many people who are putting in enormous amounts of time into any of these features. So with that, let me quickly run through the rest of the new things in PKG. So there's version manifests now. So if you're running multiple versions of Julia, you may have run into the problem in the past where one set of packages only works on one version of Julia, the other set of packages only works on another version of Julia. That can now be addressed by appending the version of Julia to your manifest files, and Julia will automatically pick up the manifest file for the correct version. Very helpful if you're using multiple different Julia versions simultaneously. Does this video work? Yes, okay, excellent. There has been a fair bit of improvement to parallelism during package installation. In particular, artifacts will now download in parallel, so if you have a big package with a lot of binary artifacts, installation of those should be sped up by downloading them in parallel. In addition, as of Julia 1.12, we will be compiling on multiple threads. So we were always compiling packages in parallel. So if you had a lot of packages, that helped. But if you had one very big package, it could get stuck in LLVM compile time for quite a while. So that is now threaded. So hopefully the overall experience should be a faster installation experience when you're installing packages. Compat will get automatically set on Julia 1.12. So when you add a package, it'll automatically install a compat entry. We hope that this will result in slightly more accurate compat bounds and making sure that when you install a package on new Julia versions, you actually get a working environment. And then there's a few minor extra flags, but let's, oops. Okay. In non-package world, I think one of the really big features that we got into 1.12 is something that I worked on, which is binding replacement. I have a full talk on that, I hope, if Claude is done writing it, at 10 a.m., so in about 50 minutes. We'll see. But I'm very excited about this, so please stick around, unless you want to go to one of the other talks, which is fine too. But if you want to hear about binding replacements, they'll be here in 50 minutes. I don't know who added that. OK. Lots of cool new things in threading. Distributed.jl was made thread safe. So if you want to combine threading and distributed, that is now safer. I already mentioned multi-threaded compilation. There were a few new improvements to the concurrency API, in particular, wait any and wait all. So if you're waiting on multiple things, including threads, you can now do that. I think one of the big new 1.12 things, which also came out of the trimming work, is these new once per thread, once per process, once per task initializers. And these are very useful to replace dunder init methods, which can be incompatible with trim, as well as declaring exactly what your intent is with respect to one-time initialization of variables. And so if you're using Julia 1.12 and you were using dunder init for some initialization work, we encourage you to look at once per thread, once per process, once per task, and pick the appropriate one for your initialization work. And lastly, there's now an interactive thread by default on Julia, so you don't have to ask for it explicitly. OK, in architecture news, RISC-V has seen a lot of work over the past year. I think Tim Bassard and Alex Fan deserve a bulk of the credit there. So RISC-V is now considered tier 3, which means that tests may fail, but things can, it's generally expected to build. Tests may fail, there may still be issues. It's not a particularly widely supported distribution yet. We also don't run it in CI yet. We just don't have any CI machines for it. But certainly, there's been a lot of progress on it. You should now be able to start experimenting with it. And we look forward to seeing RISC-V adoption continue and the Julia support for RISC-V continue to become more stable. And Tim, do you have a talk on this as well? No talk. OK, great. Next year. All right. You do have a talk on this, though. OK. So Tim has a talk on OpenCL. So it's revived, modernized, integrated with the GPU stack. I think most people know about the Julia GPU experience, but I just want to emphasize that it's really excellent. Obviously, we have vendor-specific support for CUDA, for AMD, for Intel, for Apple's graphics cards with Metal.jl, and now there's another option for going through OpenCL. So that could potentially bring Julia's GPU stack to even more vendors. So I encourage you to check out Tim's talk on OpenCL.jl. All right, codegen improvements. C function and C callable now properly participate in the invalidation mechanism with appropriate performance. So that's very useful if you're interacting with native code that gets callbacks in Julia. There's been some optimizations around memory, which was added in I think, Julia 1.11? Memory was in 1.11? Exactly. That's what I thought. So memory was added in 1.11. Now in 1.12, we gained some compiler optimizations for these. We upgraded LLVM, so you get all the latest and greatest with new scheduler models for all the latest CPUs and GPUs, all the support for all the latest architectures. Though 1.12 is on Julia, 1.12 is on LLVM 18, Julia Master is on LLVM 20. And a huge shout out to all the people who keep upgrading our LLVM. It sounds trivial. It sounds like you just need to upgrade the version number in the make file from 18 to 20, but that's not how it works. Every LLVM upgrade is a significant amount of work, and thank you very much to everybody who works on making that happen. I'm very happy that we have volunteers who go through that and track down every single issue and file them and fix them and do all of the work that's required. More vectorizations as usual, more optimizations for atomics, which again is part of the threading improvements. Okay, I think we have some, yes. Okay, I think this is mostly just intended for shock and awe, so bad code in 1.11, good code in 1.12 for this particular example on summing this particular array. So this is, you have an array with two, with the same value in it twice. Obviously, the correct fast implementation of that is just to add them. But in order to be able to do that, Julia needs to be able to elide all the memory accesses, all the array allocations, all of that. And what this demonstrates is that basically we've added enough optimizations, we've added enough annotations to the generated IR that LLVM can look through this and elide, where legal, all of the array allocations, the memory loads and stores, everything, and turn this into just the sum of x with itself. Cool. Were you going to talk about this, or?
I can talk about it if you'd like.
Go for it.
So the test suites are a little bit nicer. This matters mostly for folks who are developing JuliaLang/Julia itself. We track individual tests. We've got labels and stuff. So just a slightly better user interface or developer interface. And Windows CI is working as of, I think, yesterday.
We had an emergency workshop, the first and hopefully last emergency workshop on Windows CI on Tuesday, where we basically locked all the core developers in a room for like 6 hours until Windows CI was fixed. So hopefully it's better now. We'll continue keeping an eye on it.
Yeah, we'll see. And Keno, do you want to talk about this?
Oops. Okay. This was a little bit of a last-minute addition, but I think it's important to talk about. So I was joking that AI was writing my talk, which, it kind of is, kind of isn't. But unfortunately, I do think AI is here to stay. So, we need to think about it. And I think we need to think about it in two different ways. One is, as a community, how do we interact with contributors using AI to create pull requests, to write contributions, to make changes to the language. So there is a contributor guide in Julia now that asks you to disclose if you're using AI tools to create pull requests. So we're generally happy with people doing that. However, we want to know that you're doing it. So you disclose it in your pull requests. And B, you are still responsible for anything that you commit to the repository or submit as a pull request. So if you use AI to write pull requests, we need you to understand what it is that the code is actually doing. So if you do not understand how to fix something, ask the AI to fix it, and then don't understand the output, please do not pull request it, because that wastes reviewers' times. So that's the one aspect. I think the other aspect, though, is potentially more interesting, and that is how does language design have to change if the majority of our users are using AI? So for those of you who are keeping close track of the repositories, there have been several pull requests that we have merged specifically to improve error messages that were confusing the AIs. As an example of that, Claude likes to hallucinate UUIDs for packages, and package, when it saw a UUID that was complete nonsense, was kind of giving a bad error message. Or rather, the issue was when you had a UUID that didn't match the package, that the name of the package, basically it told you, oh, I don't know what that package is, when the issue was the UUID was wrong. So now package will check if you have a package with a particular name and a UUID that does not match what Julia knows the UUID of that package should be, the error message has an additional hint that will say, hey, maybe the UUID is wrong. And this extra hint in the error message allows the AI to recover, figure out that the UUID is wrong, look up the correct UUID, and continue. So that's a particular example. There was another example like that that I forgot in Julia itself, of just improving the error messages to make the AI better. But I think this kind of thing will be a big theme over the next year and maybe the next couple of years, is thinking about what does it mean for language development that a lot of our users will be using AI. So I don't think we have any answers yet, but I wanted to put it here because I think it's an important topic. I don't think the AIs are going away. And I wanted to make sure that everybody knew about the policy, that you have to disclose it. All right.
So Julia language development, Julia is not like a project owned by a corporation, developed by a corporation. Julia and Julia Hub are a little bit different. Not everyone who works on Julia works for Julia Hub. In fact, only a small fraction, although a lot of core developers do. And so there is not, there's not like a group of people who sit in a room, in an AI-generated room, and decide what the future of Julia language development is. And there's also not a big pot of money that's community allocated. So there's individuals, volunteers, or companies who want to do things, who are interested in doing things and do them. And that's how a lot of Julia language development happens. There's also, and this is another huge chunk, companies that see Julia as a useful tool and want to improve it in a specific way to help that company do what that company does. And that's what Julia Hub's doing, that's what ASML's doing, that's what Relational AI is doing. All these companies that sponsor JuliaCon or pay people to contribute to Julia, or pay people to contribute to packages, what they're doing is whatever they want that the upstream maintainers will accept. And so we don't have, there is no we that has control over where the future of Julia is, where resources for development are allocated. Core contributors can like gate features if they're bad. If someone's like, oh, here's an AI-generated garbage, we can be like, oh, actually, no, thank you. But we can't say like, oh, and you have to do this, and you have to do that. So there's no centralized, well-funded plan. And that can lead us to give unsatisfactory answers to what's the business plan of Julia, or what is the future of Julia. But we can try. So as a little bit of an example of the decentralized nature, this is a screenshot from last night editing this very presentation, there were 12 people editing it at once. And that's traditional for State of Julia. And the reason for that is because it's not just us, like we didn't do all this stuff. It's a whole bunch of people who did a whole bunch of things, and this is highlights. And there's also not a PR team with people to make the slides for us. Yeah, unfortunately. Also, huge part of Julia, when people say Julia, a lot of what they're talking about is packages. Like, SciML is not in Julia Lang Julia. It's not the language, it's not the compiler, but it's a big, useful resource. Maki, all these packages that people use, and more core packages like Revise. Revise is not part of Julia. That's strange. And so, lots of packages, lots more packages. Thank you to all the package authors. Okay, now we do want to speculate about the future, because some folks expressed curiosity about what is to come. So there's two parts of this speculation. One, we're going to talk about things that are already happening. And those you can kind of trust us, although who knows when they'll get here. And then the second half of the speculation is things that we haven't really started. And those, maybe trust us, maybe don't. Take it with a grain of salt. So in the works, Julia lowering. This is a really cool thing. There's another slide on that. Pluggable GC, that is, Julia has a garbage collector. What if you wrote your own garbage collector? That's better. You want to use it? That is now an option. So the pluggable garbage collector interface is done. I don't think it's marked as stable yet. And MMTK, which is a non-moving garbage collector, not the Julia default, is also available. Moving garbage collector, that means when it's collecting garbage, it like copies the data around, moves it to reduce fragmentation. Still work in progress. We've got some task scheduler updates in the works, and the Jet language server is also in the works, and there was also a talk about that previously. So Julia lowering. Just going to take a shout out about Julia lowering. How the compiler works, you get code, you parse it, you lower it, you compile it. It's pretty simple, right? It's only about 5 lines of code. That's a joke. There's a lot of lines of code. Provenance is where did that code come from? And Julia syntax keeps provenance. Our current lowering does not, but the new Julia lowering does keep provenance. And having that provenance information means we know where compiled code came from. And that means Revise can be more robust, aka correct. Cthulhu can be more robust. And JetLS can give you exact line numbers and column locations for type annotations. An important note, right after lowering is type inference, so any sort of tooling that uses types will now, once Julia lowering is ready, will have the exact location in source for those type annotations. So that's super useful, faster debugger, maybe more. Julia lowering is a keystone part of this. JetLS, there's a talk for that. It's in the past. You can watch the recording. It's cool tooling. Pluggable GC. Do you want to talk about this?
I think for the, I will talk about it briefly. I think in the interest of time, I won't talk about it deeply, but there is another talk about that tomorrow. But as Lilith mentioned, there is now a GC interface. The first consumer of that is MMTK, the Memory Management Toolkit, which is a externally developed Rust-based code base that has implementations of several traditional GC algorithms. As was mentioned, the currently working one is non-moving IMIX, and moving GC is in progress. But basically, this is of interest for people who are running long-running Julia processes. Relational AI has been sponsoring a lot of this work. You know, they have long-running Julia processes that serve their queries, and then you start getting concerned about things like memory fragmentation, about the performance of your allocators, and things like that. Some other people don't care, if you're doing lots of simulations or you're spinning up something that only runs for a couple of minutes. You probably don't care about this, but if you're running long-running Julia processes, I think this is very exciting work that you should keep track of. Okay, and just to save some time in about 5 minutes, we're going to do Q&A panel with Julia committers after this, which I will moderate. So if you're a Julia committer and you are in the room, be prepared to just come up to the front as soon as the Q&A slide goes up. And then I will moderate it. I'll start taking questions as people come up, and then have whoever is the best person to answer it answered. Okay. So there was a request to speculate about where Julia might go, and the challenge with that is that none of this has any timelines on it. But I'll do it anyway, and if it's not done in 5 years, sorry. Okay, so I think a general theme that we're seeing in Julia right now is that Julia has come to a point of maturity. So there's a lot of organizations that are maintaining large-scale Julia code bases and are running into the challenges that come with that. I think I mentioned it with the GC, comes if you're running a large-scale long-running one. But there's also organizational things like, oh, I actually want to enforce certain, features that are more interactive. I want to enforce that they're not being used in my production workloads because, we think they're too risky. Or things like, how do we actually do evolution of the language in a world where we have 12,000 packages, right? I think when we released Julia 1.0, we spent about 2 years working on various sorts of interfaces, improving various APIs, adding deprecations, and sort of dragging the entire ecosystem along with us. For those of you who are around, I think you'll remember, pages and pages of deprecation warnings with every new release. And I think the somewhat naive thought back in 2018 was, okay, we'll do that again at some point. We'll spend a year or two cleaning up all of the new things that we encountered, dragging the ecosystem along with us, and just having sort of this period where we go from 1.0 to 2.0. I think in the current state of the world where Julia is, I don't think that's feasible anymore. The ecosystem is too large. There's too many mature packages that we cannot all upgrade simultaneously. So I think there's significant interest in coming up with mechanisms to evolve the language in non-breaking ways and try to get some of these things that we thought might be in a 2.0 in a non-breaking way. So there's several items here that help with that. One is, can we use the compat annotations for syntax evolution? So say we want to change some syntax or remove some syntax because we think it's bad or confusing or what have you. If you declare a compat version that says, okay, my package is compatible with Julia 1.13 at the minimum, can we give you new syntax? So if you say my package is compatible with Julia 1.6, you get the Julia 1.6 syntax, but if you say my package is compatible with Julia 1.13, maybe we can give you a slightly different parser that disallows some bad corner cases in the syntax that we can't just remove because we don't want to break things, but that we want to discourage. Similarly, strict mode is sort of this idea that there's some corner cases in the language that are useful for interactive development or that are there for historical compatibility, but maybe as an organization who's maintaining one of these large-scale code bases, you actually just want to disallow that in your packages. So can we have an opt-in mechanism for people to say, I want to be a little bit more strict about what is allowed and what is disallowed in my packages? Export versioning, similarly, how in packages and potentially in base do you iterate on APIs in non-breaking ways so that packages that used to work with an old version of an API will keep working, but you can introduce a new API, and then once all of your users have moved on, maybe then you remove the old API. Other things that people are working on is more improvements to threading. I think threading is pretty good at this point, but we still, for example, don't run the test suite with it because there's still various known non-thread safe code in base. So stabilizing that, improving the performance, fixing all of those issues, I think is something that people are interested in doing in the near future. I think robust cancellation is a big one. There was a talk about it yesterday. There's various discussions on the issues, but Control-C has never worked great with Julia. It used to just crash Julia on 1.13. It basically doesn't work at all. So I think 1.13 might be the time that we actually look into fixing that, implementing some sort of robust cancellation mechanism, both for Control-C and for general cancellation. And again, there's a separate talk on that, as well as lots of GitHub discussion. And continued work on time to first X, time to first plot, time to first SIME, solve, what have you, as well as the new time to very first plot. So now that time to first plot is mostly okay, people have said, okay, now it needs to be the very first plot, so that includes precompile. So trying to improve that. That may be things like, okay, do we need to serve precompile files from the package service rather than having everybody compile it? Can we do further things around parallelization? That kind of thing. And then sort of part of the Julia C work, but not quite the same, is separate compilation. So can we compile modules separately? I think that's also of interest for Julia lowering and Julia syntax, all of these modules that are now written in Julia that used to be standalone libraries. Can we actually still compile them as standalone libraries even though they're written in Julia? Okay, and with that, we're going to have about 10 minutes of Q&A. So any Julia committer, please feel free to come on down. And while that happens, I'm going to start taking questions, and then I will assign those to whoever's here. All right, just raise your hand if you have a question, and Ranjan will run a mic to you. Yes, go for it. Yeah, just whoever raises the hand. I'll point in a general direction, and you just choose. Yes, go ahead.
What's the state of SIMD support in terms of how active users need to be to have it actually benefit them? Is it,
of SIMT, SIMD? Or
SIMD.
SIMD. So I guess I'll take that one while everybody's coming up. I think there's several answers to that. So I think obviously we're continuing to improve auto-vectorization support. So newer LLVM has a new auto-vectorization infrastructure called vPlan, which I'm not sure we enabled with the LLVM upgrade, but we have not.
They have not enabled upstream, so we have not.
We have not enabled it yet. We may enable it in the future. Thank you, Gabriel. So I think there'll be some auto-vectorization improvements. Obviously, there's also Julia packages for vectorization that are not standard Julia semantics, but enable use of SIMD. I think we've regressed a little bit on those, mostly because they're hard to maintain. So I think we'll need to think about in what way we want to maintain. I think we'll probably want to move those a little bit closer to core, so add some compiler extensions to make that a little bit easier. There's also things like implicit vectorization of library functions. So if you call sign, we'd kind of like to swap that out with a manually vectorized version of that, which LLVM does have support for, but now that all of the math intrinsics are written in Julia, that support doesn't apply automatically. So some work to be done to enable that. And then I think there's still a general interest in unifying the SIMD and SIMT programming models to be able to do ISPC style SIMT programming on vector lanes. But hopefully that can be done in a package with all of the compiler extensions that we've written. Yeah.
Thank you. There are 3 topics you mentioned that are of interest to me: task scheduling, garbage collection, and threading. Can you compare the expected performance of those 3 areas to other languages, especially Go, with version 1.11 and also with the improvements in version 1.12?
Sure. Who wants to talk about tasking?
So 1.12 specifically doesn't have too many improvements in comparison to 1.12. They kind of got bumped into 1.13 due to time. Go specifically does a couple things that we currently don't do that allow them to have very, very, very cheap coroutines, or Go routines it would be. So Julia's task, while close, especially if you compare them to like a straight up thread, like a P thread in C, we can go to my talk later today if you want to see about that. We're not as optimized as Go is. There's not really a technical reason why we couldn't. One of the things that Go does that allows them to be particularly good is they allow what's something called preemption, which we do not. Simply, it's a very difficult thing to implement correctly, and we haven't spent the time to do it. So hopefully with time, we will get to Go's performance. And the place where you will see a difference in performance actually is when you spawn hundreds of thousands of Go routines. If you're spawning just a few tasks, Julia in straight line code is faster than Go because we optimized slightly better of your normal code. So there might be a trade-off there, like it's how many tasks are you spawning per second, when is the trade-off? It would probably change on each benchmark, but yeah.
Will cross-compilation be on a roadmap at some point?
Yes.
Follow-up, when? I'm happy to test unstable things.
Cross-compilation is of interest, but it's one of these things that we'll get to when one of the core people who really needs it has the time for it. So I think Lilith mentioned that the way that Julia development works is that whoever has a need for it implements it. I think a lot of that work and the Julia C work has been driven by Julia Hub's needs for dyad. That will in the future include various controls hardware that needs to be cross-compiled to. So I think we'll look at it in that context, but there's no concrete timeline on that. So if anybody wants to work on that, you're welcome to. It doesn't just have to be the existing core people. We always welcome new contributors, but I can't give you a concrete timeline.
If anyone wants a concrete timeline and has a giant bag of money, that could make there be a concrete timeline.
It might also just be worth pointing out that CI is a great workaround where we have access to CI machines, or GitHub has access to CI machines that can do that. And so in lieu of cross-compilation, there are lots of machines available to do dedicated compilation.
Yes.
Could you say what someone might do to get involved in helping do cross-compilation?
Sure.
Yeah, repeat the question.
Yes, repeat the question. The question was, what could somebody do to get involved with cross-compilation and helping make that work? I think it depends a little bit on what you want to use cross-compilation for, right? One thing you might use cross-compilation for is just to make it easier to compile Julia. I mean, we heavily use cross-compilation in Binary Builder to produce binaries. So if you're interested in that, I think there's some technical work to be figured out around how to expose the difference between the build platform and the compilation platform in Julia, right? At top level, there's various conditional checks around what is the build platform. Somebody has to go through and look at those, see if those should be moved to runtime checks, or otherwise come up with a compilation model that supports that. If you're more interested in the embedded use case, then I think the first thing that needs to be done there is actually work on various embedded support libraries so that we can do things like code loading and targeting of the embedded devices easily from Julia. I think it's the ecosystem there is not mature. I actually think WASM is a pretty good target for that, just because it sort of has embedded characteristics without you having to have hardware and without your USB cable falling out and causing extra errors that you didn't anticipate. So I think for people who are interested in embedded, looking at embedded WASM quote unquote, so WASM without the big runtimes and without the GC would be interesting. But in general, feel free to get in touch on the Julia Slack with your particular interest, and we can probably point you somewhere.
Hi, thanks for the talk. Is there any plan for supporting for two different packages loading two different versions of the same package?
All right, Jameson, you want to take that one?
Sure. I think the short answer is that there's support for it, but that it is a tricky user problem. We do it now even for the REPL, because if you have created a combination of packages that would not allow you to load the REPL or PKG, it can become really difficult to get out of that situation. And so we implemented basically a way that it can load the version of REPL as shipped with Julia alongside the version of REPL that you might be trying to change, or the same for PKG. The longer answer is there because when you do that, you then suddenly have two different states of the same package that aren't interacting with each other, and a lot of packages kind of want to assume that they're interacting with each other. So it's a both answer, kind of. And I'm hoping that at some point we can also reintroduce the reload macro so that if you have a package, you've completely changed it, revise is not sufficient to fully pick up all of the things that you've changed about it. You could tell it to load the latest version and mostly ignore the fact that there used to be an old version.
Do we have any more? We do not.
I think we're done. Sorry.
Okay.
So
I think the last thing I'd like to do is recognize our new committers. I think we have a couple of people. So if you got commit access in the past year, just come up and get a round of applause. I see 2 people, 3 people maybe? Yeah, just okay. We're done. Thank you very much. If you got commit access in the past year, come between here and here so that you're on the stream and get an extra round of applause. All right, Sam, anybody else commit access in the last year?
No, we haven't.
So this could be you next year. Got to contribute more. All right, I'll be back after the ad break.